Students, and now we will be discussing about parallel combination of resistors. So when we have two or more than two resistors connected in parallel, so we can write the total resistance as what the effective resistance, or we have to find if we have to find the total resistance or effective resistance, we have to go for this simplification. When we have two resistors connected in parallel, means what? Then we can say that two of the resistors connected in parallel, then two of the ends of one resistor is connected to two of the ends of the other resistor, or both the ends of one resistor is connected to both the ends of the other resistor. If it is connected in such a manner, so then we can say two of the resistors are connected in what? Parallel combination. So here I have resistance R1 and resistance R2. Here both the ends of this resistor is connected to both the ends of this resistor. So then I can say these two resistances R1 and R2, or these two resistors R1 and R2 are connected in what? Parallel combination of resistors. Okay. So then through this parallel combination of resistors R1 and R2, I have given a voltage source V. I have V volts of voltage. So here it is a DC voltage source. We have positive, here we have negative, and then current I starts to flow like this, isn't it? From positive of the battery and it starts to negative of the battery. Is that okay? Yes. So this is how I have this circuit connection done. V is the applied voltage, I is the current which will be flowing, and I have mentioned two of the points wherein R1 and R2 meet. Okay, so here I can make out the parallel combination of resistances. This point I can point it as what? A, point B. Okay, so I am mentioning it as, and its equivalent circuit will be the same as that of this. So instead of R1 and R2, I have equivalent resistance or parallel resistance RP. I can say it as total resistance is what? Now effective resistance or parallel resistance of more total resistance of the resistors connected in parallel RP, and we calling it as RP will be equal to what? R effective or total resistance. So that is written as what? Single resistance. Instead of R1 and R2, I will be making the total resistance. I will be making out the total resistance, so that I will be simplifying this into this. So this is how I can write RP will be equal to, means this total resistance will be equal to what? Parallel resistance, or RP I can say it as, or R effective also I can say it as, wherein I have applied the same voltage V volts and current I starts to flow. Okay, so mentioning the same points as what? A and B. Fine. So this circuit is equal to this circuit. Okay, fine. So now when we have two of the resistors connected in parallel, so what happens to your voltage and current? We will see it. Okay, so when it comes to voltage drop across parallel resistors remains same. So here how is that going to be? So voltage across parallel resistors remains same. How is that going to be? Okay, so here we have this voltage. How the voltage drop remains same? So we will see that. Okay, so here we have this voltage. What is that? V volts of voltage I have connected DC voltage source at these 2 points. What is the potential difference? Potential difference at these 2 points is V volts. When I go for this point and this point, again it is V volts of voltage difference, isn't it? So here and here it is again V volts of potential difference or voltage we have. And if I go here and here it is V volts of voltage. If I go to point A and B, again V volts of voltage drop, isn't it? Correct or not? So across R1 now we have the voltage drop of V volts. If I go from here, if I come to these 2 points, again V volts of voltage. Correct? Find out. So now across R1 we have V volts of voltage. So after this point, if I continue here, here and here again V volts of voltage. Here and here again V volts of voltage. Here and here again V volts of voltage. So that I can make out that here we have voltage drop of V volts across R1. Again same voltage will be dropped across R2 also, because it is parallel combination. So R1 also will have same voltage drop. R2 also will have same voltage drop. Means total voltage V will be dropped across point A and B, wherein R1 and R2 are connected in parallel. So then both will have the voltage of V volts connect means dropped across them. Okay, fine. Is that okay? In the sense what I can say is what total voltage across this combination will be what V volts I can say it as. Okay, is that okay or not? Okay, so you shouldn't think in a manner that how much is the resistance, that much will be the voltage drop. In that manner, if you see, so you may get some confusion. Okay, so I should consider. In the sense, I should consider across these 2 points. Okay, so I should consider across these 2 points. In the sense, V will be the voltage drop across the parallel combination of resistance. Means at these 2 points, both the resistors are connected, isn't it or not? So both will have the same voltage drop. Okay, so voltage drop across parallel resistors remains same. Okay, so voltage drop across this parallel combination of resistance remains same. Same voltage V will be dropped here. Fine. So both the resistors means connected in parallel will have the voltage drop of what same voltage, that is V volts. Okay, fine. So after this we will go for the current. Current divides. Okay. So after applying this voltage, current I starts to flow here. Okay. When it comes here, so we have two resistors here. Is that okay? Okay. So then we have a road and then we have two roads which are going to get divided. Okay, so I have a single road, main road, and that goes to a junction wherein we have two roads open. Okay, fine. So if I take some example of some road. Okay, so I have a road, main road, and that goes to a point wherein it divides into two roads. Okay, fine. So this road has got certain resistance R1, and this road has got certain resistance R2. Okay, this path has got resistance R1, this path has got resistance R2. So the current divides. Current is going to divide here. Okay, so when it comes to this point, so I have main road. Main road is going to divide. So if I take current I, when it comes to this point, the current divides. The current divides into some amount. Okay, so means I can be divided into two parts, and those two parts again depends on what? The current through resistor depends on what? Means current through individual resistors depends on what? The value of resistor. Okay, what is the value of this resistance and what is the value of this resistance will decide how much current will flow here, how much current will flow here. That is how how we can make out that. So we said that resistance or resistor is what? It is a component which opposes the flow of electric current. Here if I have less opposition, more will be the current. If I have less opposition, more will be the current. If I have more opposition, less will be the current. Clear or not? Okay. So if I have more opposition, or if I say here this resistance is lesser. Okay, so this resistance R1 has got less value, R2 has got more value. If I say so, when this resistance R1 is less, so less the resistance, more current will be flowing. Fine. Okay, so now more the resistance, less current will be flowing. So that I will be divided into two currents, I1 and I2. Wherein I1 will be greater than I2 when R1 is lesser than R2. Fine. When R1 is lesser than R2, then I1 will be greater than I2. Is that okay? Here we have less opposition, because of that I1 will be more. Here we have more opposition, then because of that I2 will be less. Fine. Yes. So in this way I can have I1 and I2 as two currents which are going to divide here. Okay, when I comes here and I comes to this point and I divides into 2 points. So then we have this voltage applied, I starts to flow, this current starts to flow, and this flow of current is all to the total resistance of the circuit. Okay, how much amount of current flows here, that will be decided by the total combination of resistances. Okay, so it will make out by itself. We are now like understanding the circuit. Okay, so now we are understanding this circuit, how it is going to do so and so, and we want all these things to simplify the circuit. Isn't it or not? How that is going to come so and so. That is what we are learning now. Okay, so it will do by itself. Okay, we need not do anything. So we have to only apply certain voltage. Current starts to flow here. Current divides here depending on the resistances, and again when it comes to point B, both the currents are going to get again mix up, and I flows back to this voltage source. Okay, fine or not? Okay, so it is going to do by itself. Okay, so we now we are understanding the characteristics of this circuit to simplify it, to make out certain equations, how it is happening so and so. Fine, is that okay? Yes. So now we have applied this voltage and current I starts to flow depending on the total resistance of the circuit, and when it comes to this point here we have in different resistances. So we have different resistances means what? Current will be different. Okay, so this I can say into like what I can say is what? So I can say it as what? With some example. I have a pipe, larger pipe, which is going to divide into a connector wherein we have two pipes. Okay, so now I have a larger pipe which is going to get divided into two smaller pipes. So this is a larger pipe what I have. Okay, so this pipe will divide into two smaller pipes. Okay, is that okay? Fine. Okay, yes. So I have a larger pipe wherein water is flowing. When it comes to this point, okay, when it comes to this point, here I have. When it comes to this point, here I have a means this larger one. So when it comes to this point, it divides into two of the pipes wherein they have a narrow pipe here, and this is wider than this. So this is narrow one, this is wider than this. So now I have some I here. Fine. So means I means what? Water which will be flowing. When it comes to this point, what happens is, so this water will divide into two parts. Isn't it or not? Okay. So in general, we can say it as here less water will flow, here more water will flow. So everyone will say that. Okay, isn't it or not? How is that? Because this is a narrow pipe. Here we have more resistance. Fine. This is a narrow pipe wherein we have what? More resistance. This is a wider pipe. So here we have less resistance. That is why more current is flowing. That is why more water is flowing. Here we have narrow pipe. We have more resistance, less current or less water is flowing. Clear? So same happens here. Okay, so this is how I can go for this current I, which will be divided into two currents I1 and I2 at point A, and at point B again they will be combining. Okay, so and it will flow as what? I. Fine. Yes. So this circuit can be written as an equivalent circuit wherein R1 and R2 parallel combination. I will be taking it as what? RP or R effective. So same voltage I have applied, and I will starts to flow. Okay, so then effective resistance of parallel combination of resistors. Okay, so effective, to calculate the effective resistance, what I can make out is, so at point A, if I see I can write the total current I as what? L1 plus L2. So this I will be taking it as what? Equation 1. Okay, so I can if I go for this point A, so I can write it as what? I will be equal to I1 plus I2. So we know that current divides. Equal means not equally depending on the value of resistances. Okay, individually. Okay, so I will be equal to I1 plus I2. So that I will write it as what? Equation 1. Applying Ohm's law. If I apply Ohm's law individually across these two resistances. Okay, so if I apply Ohm's law for I1 and I2, so I can write it as, so applying Ohm's law, I can write, we know that Ohm's law is what, V is equal to I into R, okay. So if I go for I, how I can write it as, I will be equal to what, V divided by R, I can write it as, okay. So this is how I can write for current. So if I write for I1, so what will be the thing? So voltage drop across the combination will be V volts, fine. Both will have V volts of voltage across them, okay. So how I can write it as? So I can write it as I instead of I can write it as what, I1 will be equal to same voltage will drop, that is V divided by R1. If I go for this resistance, I can write for I1 as what, I1 will be equal to V divided by R1. I1 will be equal to V divided by R1, comma, what is I2? I2 will be equal to V divided by R2. Okay, I2 will be equal to V divided by R2. I can write this. Okay, fine. Is there any problem with this? No, right? Correct. Okay, I can write this as V divided by R. So for I1 and I2 I have taken by applying Ohm's law. I1 will be written as what, V divided by R1, and I2 will be written as what, V divided by R2. Is that okay? Yes. So now if I apply the value of I1 and I2 in this equation 1, if I apply the value of I1 and I2 in this equation 1, what I get is, substituting I1 and I2 in equation 1, so I will be equal to V divided by R1 plus V divided by R2. Here it is I1, this is I2. Fine. Now if I take V as common here, so I will be equal to what? V taken common, that is equal to what? What is that? V, that is I will be equal to what? V taken common into 1 divided by R1 plus 1 divided by R2. Fine. Is that okay? So this one I will be taking it as what, equation 2. Okay. So equation 2 I will be taking it as, okay. So now if what is that? If Rp is effective resistance, if I take Rp as effective resistance, so then of parallel combination, so then by applying Ohm's law, if to this circuit, if I have to go for I value, for this circuit, if I have to go for I value, I can write it as what? V divided by R effective, isn't it? Or R parallel, isn't it or not? Okay, so this is the resistance Rp. So I can write I as what, I is equal to V divided by Rp. I can write it as correct or not? Okay, so this is how I can go for this equation 3. Now this current I is equivalent to this current, correct or not? Okay, so then if I equate equation 2 and 3, if I equate equation 2 and 3, what I will be getting is, equating equation 2 and 3, I will be getting it as what? This I will be equal to this side. So then I will be equating this and this. So it is V divided by Rp will be equal to V into R1. So 1 divided by R1 plus 1 divided by R2. I will be writing. So if I cancel V and V here, so what I will be getting as a final equation is that 1 divided by Rp will be equal to 1 divided by R1 plus 1 divided by R2. So this is the total resistance or total resistance of parallel combination of resistors. So what it is, reciprocal of the parallel combination of resistance is equal to reciprocals of sum of reciprocals of individual resistances. We can say it as, okay. So reciprocal of parallel combination of resistances will be equal to what? The sum of reciprocals of individual resistances. We can say it as, okay. So and in general, or this can be written as, so for writing Rp, I can make out the thing as what? Rp can be written as what? R1 into R2 divided by R1 plus R2. This is how I can go for the parallel combination of resistance or parallel resistance. Means if I have resistances connected in parallel, so total resistance can be found using this equation. Rp will be equal to what? R1 into R2 divided by R1 plus R2. I can say it there. Okay. And in general, I can write that equation as what? In general, I can write that equation as what? It is if it is more than 2 resistances. Okay, so in general, I can go for an equation 1 divided by Rp. 1 divided by Rp will be equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3 plus goes on till what? 1 divided by Rn. Fine. So the n is what? The value of means a number of or the total number of, or we can say the value of resistance, or not the value of resistance, number of resistance. Okay. So this is first resistance, second resistance, third resistance. It goes up to how much resistance we have. Okay. So this is how I can go for total resistance of series means parallel combination of resistances as what? As a general equation, and 1 divided by R2 will be equal to what? 1 divided by R1 plus 1 divided by R2 plus 1 divided by R2, R3 and so on up to 1 divided by Rn. Okay, so this is where we will be understanding about the parallel combination of resistors or resistors connected in parallel, and this is where we will be understanding the things very clear, and this is how I can simplify the equation. And total resistance here, when it comes to the final conclusion, okay, when it comes to the total value of resistance, if I am going to calculate, okay, so if I am going to calculate for the total value of resistance or total resistance, if I am going to calculate, so what happens here is, so the parallel combination of resistance, when they are connected in parallel, when they are in series, so sum of the individual resistance will be the total resistance. Okay, so now obviously total resistance, when two of the resistors connected in series, the total resistance will be more than the highest value of resistance. So if I have some highest value of resistance, so then sum means what? Obviously two of the resistance values added together, that means what? More will be the value of resistance when they are in series. When they are in parallel, so the thing will go something different. Okay, so the thing will go something different. How it is going to be? If I have two of the resistance or resistors connected in series, also connected in parallel, if I say, if I have some resistance of 10 ohms and some resistance of 20 ohms. Okay, so or if I can I can say that what 30 ohms. 10 ohms of resistance I have, 30 ohms of resistance I have, as what? R1 and R2. Okay, so if I have to go for some parallel combination of resistance, if I have to go for, this is R1, this is R2, so then I can write Rp as what? R1 into R2 divided by R1 plus R2. I have to go for, isn't it? So then if I go for this, so what happens here is, what it is? So how I can go for this? So I have to multiply this, means I have to apply the values of R1 and R2 here, isn't it? So how I can do this is, so total resistance or effective resistance Rp is equal to what? It is 10 into 30 divided by 10 plus 30. I have to go for, isn't it? It is 300 divided by 40. Okay, so if I do this division, so what will be the total resistance? 4 tens are 400, isn't it? 4 tens are 400, means now it is 300, that means what? So the value of resistance will come out to be what? It is coming out to be some value which will be lesser than so many ohms will be coming, and it will be obviously less than what? 10 ohms. This value or total resistance value will result to what? The value which will be less than 10 ohms. Okay, so means when we have two of the resistors connected in parallel, total resistance or effective resistance will be less than the least resistance or the least resistance value what we have in parallel combination, and the total resistance will become lesser than the least resistance in the combination. Okay, total resistance will come out to be lesser than the least resistance. This will come out to be some 8 point something. Okay, this will come out to be some 8 point something ohms of resistance will be coming. So that will be lesser than the least resistance. What is that? 10 ohms. 10 ohms is the least resistance. Lesser than that means what? So total resistance, effective resistance when resistors connected in parallel, so that is going to be what? Lesser than the least resistance. When it comes to a series combination of resistance, total resistance larger than the most resistance or largest resistance. It will be larger than the largest resistance. When it comes to parallel combination of resistance, total resistance or effective resistance will be, or parallel resistance, total resistance will be equal to what? Lesser than the smallest resistance or resistor in the combination. This is how I can go for the series combination, like parallel combination of resistors. Okay, and I can have the total resistance or the parallel combination resistance as shown. So, okay, so this is all about your parallel combination of resistors. Now we will see series parallel combination of resistors. Now in some circuits, okay, so it is not always like the resistors are connected always in series, only in parallel. It is nothing like that. Okay, so we can look, we will have circuits wherein we have resistors which are connected in series, parallel, in combination also. Okay, so sometimes somewhere it will be series, somewhere it will be parallel. Okay, so in that context or in that scenario, what we have to go for is, so we have to go for both the, we have to consider both the combinations and we have to go for calculating the total resistance. Okay, so now here we will be having a mixture of parallel combination and series combination, correct or not? So that we will call it as a series parallel combination of resistors. Okay, so wherein we have resistors R1, R2, R5 and R3, R4. Okay, so means we have 5 of the resistors. Okay, so wherein, so this resistance and this combination plus this resistance all are connected in series. Okay, so when it comes to this combination, these two resistors R3 and R4 are connected in what? Parallel. R3 and R4 are connected in what? Parallel. R3 and R4 are connected in parallel, and that combination is connected in series with R1, R2 and R5. Okay, find out now across point A and B. Okay, so now to calculate the total resistance, what I have to go for is, first I have to reduce this combination. To find the total resistance, so I should go for this effective resistance as what? RP. If I go for, this is parallel combination of resistance, isn't it? So I should calculate RP first. So then I can go for the total resistance across the point A and B. Okay, so first I have to calculate RP here. So that is RP. It will be equal to what? What is that? It is R3 into R4 divided R3 plus R4 I have to calculate. So then I will be getting the total resistance RP. So then for this combination and total resistance, effective resistance R effective can be calculated as what? It is R effective will be equal to what? It is R1 plus R2 plus RP plus R5. So many ohms of resistance will be coming, okay, into picture. So this is how I can calculate the total resistance or effective resistance. Okay, so wherein I will be going for series parallel combination of resistors. Okay, so it is not always resistors will be connected in series only or they will be connected in parallel only. It is nothing like that. So we can have any combination or we can have both the combinations combined together also. Okay, so wherein we have to go for the solution or simplification of the total electronic circuit, wherein we have to see for the combinations individually and we have to make out how they are connected and how we can simplify that applying so combination rule. Okay, so this is parallel combination which is in series with the rest of the resistors. So wherein we have to simplify this first. So to calculate the effective resistance of parallel combination of resistors, so then that resistance is in series with these resistors and total resistance or effective resistance can be calculated in this manner. Okay, so wherein this is how we can go for the series combination of series or parallel combination. Series parallel combination we will call it as series parallel combination of resistors. Okay, is that okay? Are you clear of are you all clear with this? Okay, so you can calculate the total resistance of this parallel combination and as a thing, as a practice, as what some 10 ohms if I have for this resistance, I'll give some values for the individual different resistors. Then people just calculate the total resistance. Okay, so 10 ohms, 20 ohms, this is 30 ohms, this is 40 ohms, this is 50 ohms. So do calculate the total resistance. Fine. Okay. So first apply this formula and substitute the value of 3.5 for here and calculate the parallel resistance first. So you will get certain value. Okay, which will be lesser than 30 ohms. Fine. So after doing this, you will get a value of resistance which will be less than 30 ohms because parallel combination of resistors, total resistance will be lesser than the least resistance. We know that. Okay, so that will get. So then later add all the resistances. Okay, so this R1 plus R2 plus the total resistance what you have got here, and then finally the last resistance. Okay, if you add all of these things, you will get the effective resistance R effective. Fine. Okay, clear? Yes. Okay. This is all about series parallel combination of resistors.